Welcome to the lecture on section 7.3 in pre-calculus. So we have studied how to deal with systems of equations where there were two equations, but in today's lesson we are going to extend that so that we've got three equations and three variables. So go ahead and get yourself out plenty of paper. These problems are a little bit longer than what we traditionally do. So 7.3 is titled Multivariable Linear Systems. And we're going to start off by looking at a system of equations and determining whether or not the ordered triple that we're given is a solution or not. So here is our system of equations. It is 6x minus y plus z equals -1, and 4x minus 3z equals -19. And the third equation will be 2y plus 5z equals 23. In part A of this problem, we are going to be testing the ordered triple. So that means the first number is x, the second number is y, and the third number represents z in the equation. Now, if this ordered triple is a solution, it checks all three equations. If it does not check one of the equations, then it is not the solution to the equation. So here we go with our first equation. We're going to rewrite that. And then every time we run into an x gets 0, a y gets a 3, and a z gets a 1. We're going to use order of operations and simplify this down to a single quantity. So we're looking at 0 here, -3, -1. That's going to make a -4. -4 does not equal -1. So I don't even need to check the second one nor the third one. This is not the solution. Not a solution to that system of equations. If it is, it checks all three. And I'm going to do a little erasing here. And we'll try part B. Part B of our equation gives us a new ordered triple. It is -3, 0, and 5. If we're going to test -3, 0, and 5, x is -3, y is 0, and z is 5. We are going to plug those into the very first equation. So that first equation is 6x minus y plus z equals -1. So let's plug in those numbers and see what we get this time. So that's going to give us a -18, a nothing, and a 5. So that'll be a -13. So the question is -13 equal to -1? That doesn't work out either. So that tells me that -305 is also not a solution to this system of equations. All right, let's try part C. Part C, we're going to be given another ordered triple. This time our ordered triple is 0, for x, -1 for y, and z is 4. Let's take that first equation again. Let's plug these numbers in and see what we get. So that's a 0. We'll add the 0, the 1, and the 4 together for a 5. Left side didn't equal the right side either, so this is not a solution to the system of equations either. All right, here we go with part D. So for part D, our new ordered triple is -1, 0, and 5. Here we go, that first equation, we're going to plug these numbers in. And so far, so good. Again, I can't throw the towel in after I try that first equation and it works. It's got to check the other two as well. So since it passed the first one, we'll continue on our journey. 4x minus 3z equals -19 is the second equation. So we're going to plug in a -1 for x and a 5 for the z. And it passes here too. So if it passes this final one, we have found a solution to the system. The final equation is 2y plus 5z equals 25. So if y gets a 0, z is a 5. And a check on that too. So yes, -1, 0, 5 is a solution to that system of equations. So this is just the checking process. This is not us starting an original problem and solving it. So I'm ready to go ahead and make that transition though to solving, and we'll start off with a very simple system of equations. So here's problem number 2 for us. So our first equation is going to be x minus y plus 5z equals 37, y plus 2z equals 6, and then z equals 8. Now for this problem here, we're going to be able to solve it using what's called back substitution, because we already know what one of the values is for the variable. So if we back up in our system to our middle equation, we know that z is equal to 8. So if we go ahead and plug in that z is equal to 8, we have now set up an equation with one unknown, and we just need to solve for y. So 2 times 8 is 16. And subtracting that 16 will give us y equals -10. And then we back up one more layer in our equation. So x minus y plus 5z equals 37. We know what y is. Watch your signs again. And we also know what z is. So that's going to be a plus 10 and a plus a 40. On the left side, the 40 and the 10 will add to a 50. And then all we need to do is to get rid of that 50, and we will have found the solution. With these problems, you're going to see that you've got a lot of different equations going on. You got a lot of variables going on. We always want to write our answers in ordered triple: x, y, z. So cleaning it all up, x is -13, y is -10, and z is 8. That's our ordered triple. So this back substitution, you are literally just backing up your equation and plugging in what you know until you have got all 3 of those solutions. I'm going to try one more like that before we go into a full-blown problem. Here's question number 3. Let's say that we've got x minus 2y plus 2z equals 20, y minus z equals 8, and z equals -1. So again, we've got this back substitution. We're going to be able to back up to that middle equation. In that middle equation, we now know what z is, so we'll go ahead and plug in the place of z to be -1. So if you wanted to write +1 instead, that would probably make it a little bit easier for you. Because as we solve this equation, we're going to need to get rid of that 1, and to get rid of that 1, we would need to subtract it. And then we move to our top equation. We know that y is 7. We know z is -1. That's really -16 on the left. And then we add that 1636. So I'm looking for an x, a y, and a z. All right, so let's go ahead and make the transition to a full-blown problem. A full-blown problem is going to have 3 equations and 3 variables. We have the potential of getting 3 different answers. We can get an ordered triple like we've seen in the last 2 problems. Some of these systems of equations have no solution, and some of them have implementing solutions that we'll need to write in parametric form. So let me give you some steps. Our first step is to use the first and second equations and get rid of x. This will give you a new second equation. The second step will be to use the first and third equations and get rid of x again. This will give you a new third. Then we're going to use the second and third equations. This time they will not have x's in them, so we'll move on to the next variable. We'll get rid of y. And this is going to give you a new third. And then we'll use back substitution to find the remaining answers. And again, that will give you that ordered triple. My suggestion to you, because these problems are going to be much longer than what we normally deal with, if you'll make sure you just do 1 problem per page of paper, that would be perfect. Now I'm going to be writing across my screen so that I can see the equations as we go. You're probably going to be writing a little bit across and then also going down into the bottom of your paper as well. So here is our first full-blown problem. Two x plus 4y plus z equals 1. X minus 2y minus 3z equals 2. X plus y minus z equals -1. Now, as we progress through our problems, you're going to see me slow down and many times check to make sure that I copied everything correctly and that I've done my arithmetic correctly. The last thing I want is a whole page of paper that I made a careless mistake in the first step and I'm balling it up to toss it in the trash can. All right, so our first step is to use our first and second equations. So let me write them down completely all over again. and we need to eliminate x in those equations. So back in section 7.2, when we learned that elimination method, we know that we can cancel out variables very quickly as long as the numbers are the same, but the signs are the opposite. So if I can just get that bottom one to be negative 2x, it's going to go. So that means everything gets multiplied on the bottom by negative 2. So let me recopy the top one since we're not changing that. The bottom when we multiply by negative 2 is a negative 2x, a positive 4y, a positive 6z, and a negative 4. And then I'll be ready to add column-wise. When I add the x's, they cancel. The y's make 8y, the z's make 7z, and the plain numbers make a negative 3. This is going to be your new second equation in the system. So every time I have this little brace off to the side, that means I've got a new system of equations. That's where I'm at the moment. All right, so the next step. The second step says we need to use the first and the third equations in the system. So let me write down the first one and the last one. And again, we're going to focus our attention on we've got to get x by itself, or to get rid of x out of the equation rather. So again, if I multiply the bottom equation by negative 2, I'm going to see then that the x's are going to cancel out. So that's negative 2x, negative 2y, positive 2z, and a 2. So the x's eliminate, the y's make a 2y, the z's make a 3z, and the plain numbers also make a 3. This is going to be the new third equation in the system. So we still have our same first. We've got that new second equation that we calculated, and now we've got the new third equation we calculated as well. So now that we're in the third step, we're going to use the second and third equations. We're not going to be able to get rid of x when we complete this step because clearly there are no x's in either one of them. So we're going to transition now into trying to get rid of y. So if we've got an 8y on the top, a negative 8y on the bottom would cancel it out. So to accomplish that, we just need to multiply the bottom by negative 4. So that will be negative 8y, negative 12z, and a negative 12. So the 8y's go. We've got now a negative 5z, and we've got a negative 15. So let me just go ahead and finish this up. If I divide both sides by negative 5, I'll have z equals 3. Now in this system, that is the new third. And that finally puts us back at how we worked questions 2 and 3 today. It is back substitution that's going to help us figure out what y is, and then back up one more time to figure out what x is. So as we go to that middle equation, we now know that z is 3. And I'm going to keep on solving for y. And then if we go to the top, we know what y is, we know what z is, and we're very rapidly going to be able to figure out x. So you probably got, again, a whole page of work. We need to wrap all this up so that we've got our answers at order triple XYZ. So that's going to be 5, -3, and 3 is a solution to your system of equations. So that's how we can work one problem. We work it all the way out, and when we get done, we got a value for X, Y, and Z. We've got that ordered pair, that one solution to the equation. So like I said earlier, there are also times in which we're not going to be getting that ordered triple. So I want to work a couple of those problems so that you will see them as well. So here's question number 5. Again, fresh sheet of paper. We have x minus 3y plus z equals 1. 2x minus y minus 2z equals 2. X plus 2y minus 3z equals -1. So looking at it, we're not going to know that something's wrong with it. It's going to be as we get into the math that things kind of go a little astray. So let's go ahead, in that first step, we're going to pull out the first and second equations. And using that first and second equation, we need to get rid of x. So I see down in the bottom, we've got a 2x. If I can just make that top a -2x, it's going to cancel out. So I'm going to multiply everything in the top by -2. So that will make -2x, a positive 6y, a -2z, and a -2. And then we do not need to alter the bottom equation. So toodaloos to the x, the y terms make 5y, the z's make 4z, and the plain numbers make a 0. So that's going to be our new middle equation in our system. Right, now that we're in the second step, we are using the first and the third equations. So let me rewrite those. And with those equations, we need to get rid of x. So they're both x. We just need one of them to be a negative one. It does not make a difference which one you multiply by -1. I'm just going to elect to choose to go with the bottom one. So we got the x's to cancel out. That's now going to make -5y, 4z, and a 2. So that is going to be the new third equation in the system. So things are coming along like they normally would. So as we get to the third step, we use the second and the third equations. And we need to get rid of the y. Lucky for us, the y's are already going to cancel out, so I don't need to alter the equations. And in fact, the z's cancel out too, so that leaves me absolutely nothing on the left side. Over on the right side, 0 plus 2, that's 2. So when your variables cancel out, that's that indicator that you're getting ready to have one of those word answers and not the ordered triple like we saw in the previous problem. Now 0 and 2 do not equal one another, so that's what makes this one no solution. There are plenty of ordered triples that work the first equation and the second equation and the third equation. There's probably even ordered triples that work the first and second, second and third, and first and third. But there's not one that's going to work all three equations at the same time. All right, let's go to our next problem. That's going to be question number 6 for us. Got a brand new system. This time we've got x plus y minus 3z equals -1. We've got a y minus z equals 0 and a negative x plus a 2y equals a 1. Again, looking at it from the perspective of copying down the new problem, it's not going to signify to me that anything is messed up about this problem as far as the solution until I get further into the work. So when I first look at that, that I know that my first step here is going to be to get rid of the x, and I'm going to go into the next part with an equation that doesn't have an x. So lucky for us, we're not even going to have to do that step. We can go ahead and move to the part where we're going to use the first and the last equations and get rid of x. And this is our lucky problem because the x's already cancel out anyways. So the y's are going to make 3y. We got a -3z, and the plain numbers cancel out too. So at this stage of the game, we are ready to use the second and the third. And since the x's are gone, we got to figure out how to get the y's gone. So I see the bottom one is leading off with a 3y. If I can make the top one a -3y, we got this one. So that would be a -3y, a +3z, or z rather, and then just a 0. And then the bottom equation, we didn't need to alter at all. Now the whole purpose of going through those steps was to get the y's to cancel out, and that happened. And we also got the z's to cancel out, so there's nothing left on the left side. When I move over to the right side, the 0 and the 0 give me another 0. So when we were doing number 5 and we got to that stage, we had two numbers that were not the same, which made it no solution. So here, when we get to the same phase that the variables are gone and I'm comparing these last two numbers, they are equal, and that's what makes this answer infinitely many solutions. Now, infinitely many solutions is very misleading because it's kind of like, oh, well, I'll make up any three numbers I want and it'll check all three equations at the same time, and that's not how that works. So what we've got to do is write it in parametric form, which is then going to allow us to come up with the formula to come up with the ordered triple answers to this. So what we've got to do is to take the last variable z, and we just need to set it equal to another variable. So your book and also WebAssign like a, so I'll stick with a. So the rest of the time we're going to be doing back substitution. So let's go to this middle equation. Y minus z equals 0. I know that z is equal to a. Now remember, my ultimate goal is to still have an ordered triple. I need an x, a y, and a z. So I got the z, and if I can solve this for y, I'll have y. So we'll end up adding a to both sides. And then let's move to the top. We know that z is a and y is a. That's not always going to be the case that both of them are equal to a plane a, because most of the time they are not. You may even have to use the distributive property as you continue to solve these equations. So if we can get x by itself, we've got our answer for x. So we need to add 2a to both sides. So you can write that the way that I have wrote it, or you can flip that around as far as the order. It makes no difference. So our answer in that ordered triple format is 2a minus 1 for x, a for y, z for is a as well. So anything in this format will be a solution. So if I said, okay, let's let a equal 5. So I got a 5 here, a 5 here. 2 times 5 is 10. 10 minus 1 is 9. So the ordered triple 9, 5, 5 works as system of equations. If I let a equal -3, that'd be -3, -3, 2 times -3 is -6, minus 1, -7. -7, -3, -3 is also a solution. So this right here is the actual answer you would put in WebAssign because it is the formula that gives us the ordered triples that do check all three equations at the same time. So hopefully in today's lesson you saw how to build off of having two equations with two unknowns to three. We looked at checking ordered pairs, ordered triples, to make sure that they were solutions. We learned how to do back substitution before we got into those full-blown problems where we could see an ordered triple, no solution, or infinitely many solutions. So at this point, I will let you go ahead and begin your work in WebAssign on section 7.3, and I'll see you in the next lecture in 7.4.